logs in Algebra 2. Logs are inverses of exponential functions, and we just studied exponential functions, and now we're getting into logs. So this is the definition of a log, right here. Log of base a of x equals y. If you want to put this into exponential form, it's a to the y equals x. A to the y equals x. Okay, here are some laws of logs. If it's in log form, you can put it into exponential form, just like I showed you. 5 to the second equals u. That's probably the most important law of logs, is how to go from logs to exponential. The log of any base, 7 of 1 should equal 0, and I'm going to check it by putting it into exponential. 7 raised to the 0 equals 1. Anything raised to the 0 is 1. It doesn't matter if this is a 4 and this is a 4, it should always equal 1, or the log of 8 should equal 1, and I can check it. 4 to the first equals 4, 8 to the first equals 8. And this one, the log of 7 to the x, I can take that x and I can move it out in front. So it's the log of base 7 of 7, which is equal to x, because on property 3 says that equals 1. So these are some of the laws. In 5.5, I think we go over even more. We even go over more logs, so laws of logs. So, I guess we're going to keep going over them. So this is a really, really important one. This will be on the test. This is equal to 2. So if you see 6 log of base 6 of 3, these two have to equal the same to equal to 3. So remember that. Might trick you. They might give you 5 to 2 log of 5 to 2, but you can take that 2 and put it up here. As long as these two are the same, it's going to equal this number, which is 4. So remember that one. That one's on the ACTs too. Okay, this one, log of both sides are both log of 7, x must equal 3. If there is no base number, it's understood as a 10. So 10 to the x equals 100. 10 to the second equals 100. And now the last three, 8, 9, and 10, natural log are base e. So it's e to the 0 equals x. X equals 1, because anything raised to the 0 power is 1. And if there's a little e here, e to the first must equal e. And if you wanted to change the base, it's the log of the bigger number, 8 over the log of 3. And your calculator can do the log of 8 divided by the log of 3. And then the log of base 3 of x equals y. Let's say you had to do this one and you had to graph it. And let's say you didn't even have a graphing calculator. You know that it's 3 to the y equals x. Let's say you had to graph this one without a calculator. 3 to the y equals x. So all I'm going to do is plot my points. I'm going to let y equals 0, y equals 1, y equals 2, and y equals a negative 1. Let's do this again. Let's go y equals a negative 1, 0, 1, and 2. When y is a negative 1, you get 3 to the negative 1 power, x is 1/3. 3 to the 0 is 1, 3, and 9. And if you graph it, x is 1/3 and down a negative 1, 1, 0, 3, 1, 9, 2, and it looks like that. Make sure you put a vertical asymptote on there. Okay, that was the introduction. Now we're going to go through all the parts. So here's the parts. This is an exponential form. They want you to put it into log form. So the log of base 7 of 100p equals x. So it's an exponential form. They just want you to put it into log form. Part 2, it's in log form, and they want you to put it into exponential form. So 3 to the negative 5 equals 1 over 243. Part 3, log a base 10 of 10,000 equals 4. You don't put the 10 down there, remember. If it's not there, it's understood as a 10. There's a little 10 there, so it's 10 to the negative 8 equals x. Just going over all the laws. Change into log form, and a is the base number, so this is a little confusing, but what you need to do is get a alone in this problem for part 5. So all I'm going to do is I'm going to subtract d, and I'm also going to divide by b. They're telling you that the a is the base number. So now that you have the base number, you're going to do the log of base a of f minus d divided by b equals t. And I can check it by going from log back into exponential. A to the t is equal to f minus b divided by b. So I know I did it right. Okay, part 6, all they're going to do is ask you to find x using all your laws. So what I would do is I would put the 4 out in front. Remember that this is one of the laws, the log of base 8 of 8. This equals 1. So 4 times 1 is 4 equals 2x. X equals 2. There's another way if you want to do it, but I think this is a quick way of doing it, so don't even worry about that other one. Solve for x. So let's just solve for x in all of these. Notice that they both have a natural log on both sides, so you can set x squared equal to 12 minus x. You cannot factor a quadratic unless the right-hand side equals 0. X plus 4, x minus 3 equals 0. X equals a negative 4, and x equals 3. And it works. You can check your work too. As long, you can have a negative 4 for an answer, as long as when you put it back up in here, it becomes a positive. Do you see that a negative 4 squared ends up being a positive? If it ends up being a negative when you put it back up, let's say the natural log of x, and you were to put a negative 4 back up here, then it's a no solution, because you cannot take the natural log of a negative number in that. Okay, do you notice that there is a natural log on both sides? This one only has 1, so all you do is you put it into exponential form. So x equals 9 plus 4 is 13. And wow, we got 3 pages left to go here. They want you to graph the log of x plus 2 and f of x equals the log of x plus 2. So, you know what a log graph looks like? The log graph looks like if this is the inverse of an exponential function, remember an exponential function goes through 0, 1 like that and has a horizontal asymptote, then the log has to go through 1, 0. Instead of having a horizontal asymptote, it has a vertical asymptote. This is exponential, and this is a log. And you can see now that they're inverses of each other. So all they want you to do in this problem is this is the log of x of any base number. They want you to move everything up 2, and they want to move everything left 2. So what does an up 2 look like? Well, it used to be at 1, 0, and it got moved up 2, and it looks something like this. So this is this one right here. And then I'll do the red one. This one is you move everything to the left 2. Well, remember the original one used to be here at 1, 0, so you're going to move to the left 2. It's right here. There used to be a vertical asymptote, so now you're going to move it over here, and you make your inverse. So everything got moved to the left. Even the vertical asymptote needs to be moved. Graph is given, you're supposed to find the function. Graph is given, you are supposed to find the function. So the log of base A of x equals y. So when I taught you logs, this was the equation that you were given to learn about logs, and we learned how to do the loop-de-loop, you know, the a to the y equals x. So all you're going to do is log a base A, in place of x, you're going to put an 8, and in place of y, you're going to put a 3. So a to the third equals 8. What number to the third power is equal to 8? Isn't it a equals 2? So your final answer is, I just found the equation of the log of base 2 of x equals 1. Everybody see what I did? I knew that it went through those points, so I just put her in there. And I think we're at the last part. This is the graph, and they want you to translate the graph. So that's the graph, and they want you to translate it. They want you to move it down, or to the left 2 and down 1. Left 2 and down 1. So here's the point. We're going to go to the left 2 and down 1, which would put your new point right here. You go left 2 and down 1. The asymptote gets moved over also 2. And then you make yourself your log graph. And that's it for the notes for 5.4.